Welcome to the 60th episode of PEEPanEIP, an educational video series where we learn about an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm your host, Pooja Nandan, and today we are going to talk about EIP-1967, that is standard proxy storage slots, with our special guest, Hadrien Croubois. EIP-1967 is a standard track proposal of ERC category drafted in April 2019. The proposal is currently in review status. However, there is an open pull request for it to be moved to the last call. We will talk about it and more in the episode. First, let's meet Hadrien, who is a smart contract engineer at Open Zeppelin. Welcome to the show.
Yes, thank you for having me. And before we start, I'd like to point out that this ERC or this EIP was introduced by Palladino and other members of Open Zeppelin. I'm presenting it today because I'm actively working on it, but I'm not the very first original author of it.
Noted. So today's topic is really very special for the dapp developers. As you can hear, we have one of the Open Zeppelin developer here. This is special to the projects that deals with delegating proxy contracts. So I'm looking forward to learn more about the proposal. But before we get there, may I request you to share a bit on your background and how you stumbled upon Ethereum?
Sure. Well, I heard about Ethereum a long time ago and didn't really pay much attention, even though I should have. I really came across Ethereum during my PhD. I did a PhD in France at École Normale Supérieure de Lyon on distributed systems. And my PhD advisor was sharing his office with Gilles Fedac, who happened to be one of the co-founder of iExec, which is a French startup that had an ICO in 2017. So Ethereum was already a few years old, but it was like the early ages of Ethereum. Gas price was cheap, and they wanted someone to help them design their protocol and implement it in smart contracts. And that's something I did during my last year of PhD, designing the protocol of decentralized actor like I was used to doing, but with this special touch that we could use the Ethereum blockchain as like a central scheduling actors. And usually in distributed system, we try to avoid this kind of centralized systems. And the blockchain is not centralized, but it can be seen by lots of computers as like a centralized database, even though it's not. And this was very, very powerful to me. And this is what brought me into the Ethereum ecosystem as a way to implement distributed designs. And during my first year at iExec, because I continued working there after my PhD, I had the opportunity to attend a lot of community conferences, learning about the ecosystems, being an Ethereum magician, learning about the cat herders, all that interesting stuff, and about the ERC and EIP process. So that's what led me not only into Ethereum, but also into this track of standardization and building stuff that is interoperable, because that's also one of the big strengths of Ethereum.
That's pretty interesting backstory. Yeah, it's always fun. And I think this is the most fun part of the talk. I love to meet people, amazing people coming into the blockchain space, especially when they are coming directly from finishing their education and just jumping into the blockchain industry. So it was great to hear that. Getting back to today's topic, we will be having an overview of proposal 1967. Before we go there, let me make a special mention of another guest, Francisco. He is from the same team, and today he is supporting to learn more about the proposal. Thank you both for joining us. And without further ado, let's peep in.
Okay, so maybe we can go to the first slide, Fran. So the first thing I want to discuss is like this proposal is about proxies and upgradability. And the first thing is I want to give an overview of what is my vision of this space. Obviously, maybe many people might have other opinions, but I think this vision helps understand what scope this ERC applies to. And the first thing is that a proxy is usually a smart contract that can either directly call another smart contract or use a delegate call route. If you directly call other contracts, that means that the storage you are working on is another contract. And then your proxy is basically a routing call. And this can be interesting, but it's not really where upgradability works. When you are on the delegate call route, this means that even though you are using the code of another account, another contract, you are using your own storage. And this is where upgradability works because the proxy storage space is what's actually being used. And here I would divide it into two big categories. There is what I would call the vtable space. I mean, that's from my background in C++, but that's what the diamond pattern that is described in a few ERCs goes. And basically this is where, depending on the message signature, you're going to redirect to different modules. But there are simple proxies. This is where what we are focusing on. It's like the single implementation space. And that means that it's a proxy that's going to delegate, and it's going to delegate all the calls that are incoming to a single implementation, a single address. And again, here we have different possibilities. There is a clone pattern that is ERC-1967 that is particular because the address that is being delegated to is in immutable storage. It's part of the code and it cannot be changed. So this is like a very small proxy that is non-upgradable because the address of the target is fixed. And then there is the upgradable one that stores the address into storage so it can be edited later on. And those are either the upgradable or the beacon one, which is something that Open Zeppelin introduced and we are going to discuss. And basically, this is the scope of ERC-1967, those upgradable and beacon. So those are proxies that use delegate call to target an implementation, and the address of the implementation is in the storage space. It's not immutable storage. It's not immutable values. So maybe you can go to the next slide. So yeah, this slide is just a summary of that, and that's maybe useful for people that don't have the call, but it's delegating call, single implementation, upgradable. And yeah, that's it. And so the next slide is about what ERC-67 specify. And ERC-67 is mostly about where in the memory space, in the storage space of a contract, should the address of the implementation and on the related values be stored. Because when you are using this kind of proxy, one of the things that is important through upgrades is the consistency of the storage layout. If you have a smart contract, values are going to be stored. And if you are writing in Solidity, and I think Vyper does the same, it's starting at slot 0, and then it's increasing. And whenever you had a value in your contract, it's a new slot. And basically what's happening is that the linearized version of the contract determines which slots are used for what. And if you do an upgrade and you modify the order of the variable, or you do it differently, then it's going to mess up everything. You are going to override values, or you are going to read from the wrong values. And when you do an upgrade, usually you focus on the actual logic of the contract. But one of the storage that is important is actually the address of the implementation, and that's only used by the proxy. It's not used by the implementation itself. But it's important that this is kept safe across upgrade, and that it's not overwritten or modified by mistake. And the idea is that we should not use the first slots that are assigned by Solidity and by the contract. For that, we should use a very specific slot, so a very specific index in the Merkle tree of the storage of this account to store this value. And this is true of the logic for like simple proxies. This is also true of the admin address when you have a proxy that contains ownership mechanism to do the upgrade, which might be, we want to separate from the logic of like ownership of the contract if it's an ownable contract that the proxy is pointing to. And there is a beacon contract address if it's being used. And the beacon approach it's interesting in the sense that sometimes you don't want to store the address of the implementation in the proxy, but in another contract. And you just want the proxy to use that contract as a reference. And this is very useful for upgrading a lot of contracts at once because they're all pointing to the same beacon, and you can just upgrade the value in the beacon. So that's why we want to differentiate between whether it's using the beacon as a relay mechanism or not. And additionally to specifying those three particular slots, we're also defining 3 events. Yeah, so those are the slots. So basically, those are just hashes of strings, and there are arbitrary values, and that's the whole point, is that those should not conflict with anything else, because it's not very low values, and since they are like explicitly the hash of strings that have been determined for this, um, it I mean it's realistically impossible to have collision, or we don't expect to have any collision on that. So it should be like slots that nobody else should be using, unless they are specifically trying to use this specific mechanism.
Is that because of how far into the storage they are that you don't expect there to be any kind of overwrite? I mean, most of the storage in the contract, I assume, is written from the beginning of the contract, but I believe that mappings probably work a bit differently. So
Yeah. So yeah, most of the storage starts from the beginning, from the zero value, and so that's what's happening here. And then when you have a mapping, it's happening by hashing the key with the index of the mapping. And if mappings are nested, then you have nested hashes. But this being the hash of like this string with no particular prefix, that could potentially be like the slot of a mapping. We could technically have hash collisions with something in a mapping, but it's extremely unlikely. I mean,
But also,
yeah.
Also note that these are not exactly hashes, but it's the hash of a string minus 1. And that is like an additional protection that someone suggested in order to avoid this potential conflict. But just being the hash of a string itself is enough to guarantee that if there is a collision with a mapping value, that implies that kekak, the hash function was broken.
Oh, that you've got a collision with the hash function then.
Because
got it.
The pre-image, because of the way it was defined, will not conflict with a mapping as latent in storage by Solidity.
I understand. Thanks.
Yeah, and on the next slide, we have a few events that are defined that should be emitted whenever one of these slots is updated. And that's because it's not easy. I'm not sure it's even possible with current tooling to just react to one particular slot changing on like any contract. But it's possible to listen for these events to identify from tooling that, yeah, this contract actually implement this kind of features and the slots was changed during an operation. Like, for example, the upgraded event is an event we share with other implementation, but the beacon upgrade is something that is particular because I don't know any other implementation of the beacon design. Also, the admin changed is purposefully not the transfer ownership event, so that you are able to differentiate between proxy changing its owner and the underlying contract being like ownable and triggering transfer ownership. So on the next slide, we have basically what this implies, and that this tree storage slot existing means that whenever you have a look at an address, basically you can have a look at the storage slot for implementation. And if that's non-zero, then you have a very strong clue that this is a proxy that is using like a direct redirection to this particular address. And so you know that this is basically the address of the implementation. If this implementation slot is 0, and if the beacon slot is not 0, and both should not be non-zero at the same time. It's either one or the other or none of those. If the beacon slot is non-zero, then you know that it's also a proxy, but you know that if you want to get the address of the implementation, you should not use this slot. You should interpret the value of the slot as the address of a beacon, and you can call the implementation function on the beacon to get the actual address that the proxy will use. Last but not least, there is this admin slot, and in many cases this will be 0. But if this is not 0, then you have again a very strong clue that the address that is stored there is the account that is authorized to do upgrades for this contract. Obviously, upgrades might be done in a different way. That's what the UUPS pattern does. Maybe we will discuss that later, but it's just like if you have these slots being set, you have strong clues. If those are not set, then you cannot say much about the contract, but if they are set, it's very, very strong ideas. And on the next slide, we see that these slots are being used by our implementation. We have the ERC-1967 proxy that uses the implementation slots, but doesn't have a built-in upgrade mechanism, so it doesn't use the admin slots. We have the transparent upgradable proxy that is a proxy that self-contains upgradability mechanism. This one uses both slots, so the implementation and the admin slot. Open Zeppelin also has the beacon proxy. This one uses the beacon slot, and it's not modifiable by default. So the proxy by default doesn't have the ability to upgrade from one beacon to another, even though that can be done in the implementation. And it's mostly the beacon that implements the upgradability feature. Those are for the Open Zeppelin implementation. I also discovered that other contracts, particularly the Ethereum proxy. So Ethereum, I don't think it's live anymore, but it used to be a smart contract-based wallet. And it used proxy to make creation of wallets for new users as cheap as possible. And they use the same slot as we do. Basically, they follow the CRC. So the question is, why should we standardize that? And there are two things. The first thing is we want to promote good practice. And the good practice is to isolate the proxy specific values, like where to implement, from the storage needed by the underlying values. For example, if you have an upgradable ERC-20, you have your symbol, your name, your total supply, your allowance, your balances. Those are like specific to ERC-20, and those should be separate from the actual address that is used by the proxy for doing this upgradability thing. And we want, I mean, everybody, I think, in this space understand that it's a good practice to isolate that, and we want to isolate that outside of like the first few slots. So we need to agree on where to put it, and this is what this CRC is all about, is agree on that. And once we have this agreement, then we know that proxies will not conflict with one another. If one proxy wants to point to a logic that has the ability to upgrade the proxy, then it's going to work together. Also, tooling can be improved. For example, if you go to Etherscan, and I'm sure a lot of maybe you, or at least the viewers, have done that. When you go to Etherscan, you have the ability to read the contract and not to write transaction directly connected to MetaMask. But there is also this read as proxy and write as proxy that appears when you are interacting with a contract that is a proxy. And this happens not with all the proxy, but it's happened with the ERC-1967 because MetaMask is aware of this standard that is in this ERC and is able to use that to expose additional info to the user. That's really what this ERC is about. It's not just about contract. It's about tooling that is going to inspect and help. In this case, it's mostly developers, but it could also be end users in the end. Yeah, and that's it for the presentation. Those are what we put at the end, documentation for Open Zeppelin, but that's it.
Well, thank you so much for this presentation. It was super helpful to understand the types and the requirement for proxy in different projects. First of all, I would like to open the platform for our questions. I already see there are some questions in the chat. Alita, if you would like to go for it.
So I'm trying to kind of gain some clarity a little bit on the way that this hashing works, or like the beacon slot, like the key. And specifically what I'm wondering is, if you know of like I think it's both valuable for my understanding as well as maybe for others who aren't aware of like how Solidity works. If you know how to kind of relay how this would work in, say, like Python or something, or some other sort of standard, more popular language in their data structures of like objects, I assume.
Okay, so So what you have to keep in mind is that these slots, that the way we end up with this number is not really important. Those numbers are just, to all intents and purposes, those are just random slots. And by taking random slots, we avoid conflict. It's just the way we generate the randomness. We do it in a way that shows that we were unbiased and we are not including any backdoors when creating this randomness. But in the end, these numbers are just fixed. And if you are not able to reproduce the hash in any language, you can just use the fixed value. It's going to be used in the smart contracts or either in Solidity or in Vyper to read values, or it's going to be used by tooling like JavaScript or Python tooling that would want to inspect the blockchain space. This would be done through a provider. So I'm mostly familiar with Ethers or JS, but all providers have this. I mean, you could even do it directly in RPC command. There is this ETH get storage at, and you would just put the address of the contract and this arbitrary value, and that would allow you to read the storage. Does that answer the question?
Yeah. So then would that mean that the for all contracts that utilize this standard, would they have the same, be utilizing the same storage slot?
Yes.
Okay. And how would that work? Assuming that you have to like have different values at that slot, or is that
no? Okay,
right?
So each contract has a memory space that is its own, that is not shared with other contracts, and it's like when you have, I don't know how people are familiar with like OS development, but each process has its own view of the memory, and expect from very specific cases, like all things are alone in the system, and like each smart contract has a completely available storage, and like all 2 to the 256 slots are supposedly empty, and contract A and contract B can write to this slot number, and it would not be shared. It would be each in their own view. And basically what happened in that, in the grand tree of all Ethereum state, what you have is that you first go from the root of the tree to the contract, and then inside, once you reach the contract, you go to the storage slot. So tens of thousands of contracts can use the same storage slot. It's just an identifier. In their own point of view, the same slot, but there is no write or read conflicts between them.
Thank you for the explanation.
Thank you, Alita. So I have a few questions related to the proposal. I understand that you are not the author, so I will try to put questions with respect to Open Zeppelin, but if you have answers to any of the questions that may be addressed to author, please feel free to let us know. So in the presentation, you did talk about why standard. So we understand the reason for why we should have a standard. It's actually a very good reason we should want the ecosystem to be following same proposal, same standards. We know that there were other proposals for proxy and delegating proxy standards such as EIP-1967, EIP-1822, that is universal upgradable proxy, and even the proposal 1967, they have mention of this. My question is, so for Open Zeppelin, is EIP-1967 the first proposal that was implemented?
So just, you mentioned a few ERCs. I'm not familiar with all of them. I'm familiar with 1822, and those are not conflicting EIPs. Those are complementary EIPs. 1822 is a way to advertise that you are upgraded, that it's for an implementation. I mean, it contains a lot of description of how proxy should work, but the actual technical proposition in 22, and Fran can correct me on that because I know he also knows the ERC, but the actual proposition, technical proposition of 1822 is how an implementation should advertise that it's supporting proxies, and that a proxy can use that as an implementation. And in fact, what's happening is that not only those are complementary, but in one of our implementation, what we call the UUPS proxy, we are using EIP-1967 for storing the implementation. And then we are also using 1822 for securing our upgrades. So to come back to your questions, there were efforts in Open Zeppelin to build proxies before 1967. And the fact is that the very first version of Open Zeppelin contracts used a different slot because we used a different preimage that was very Open Zeppelin specific. And we used that with the proxies that were deployed by the ZOS. So it was a CLI for upgradability. And at some point, there was this effort that this is not just an Open Zeppelin tooling and Open Zeppelin contract. And that's when we moved to other storage slots that are more generic, that are not really open. There is no mention of Open Zeppelin in the way they are computed. And that's where we put an effort towards standardization. So we're not trying to fight other ERCs here. We're trying to add something that complements other existing ERCs.
Well, that's very good to know, because I was wondering, we have the guest author of the proposal 1822 in the past. I think it was about 1.5 years ago when the proposal was actively pursued. And currently the status of the proposal is stagnant. So it was conflicting to me, like why we are having a competitive proposals, and what makes 1967 a unique or a special that can be proceeded towards being a standard.
Not only it's not conflicting, but we are also considering reviving 1822 because we think it's a good addition to our security ecosystem that we are developing with a contract like Open Zeppelin. And we will soon do, I don't know what the process, but a PR to slightly modify it and to reopen discussions on this ERC.
That would be nice, because 1822 is another one of a kind proposal, and I hope that it will be used. I mean, as you mentioned, that the Open Zeppelin is already using this for some other purposes, not exactly the way 1967 is being used. So, but it would be good to have complementary proposals. Thank you. My next question is about EIP specification, that is the limitation to the contract language. So as I understand by reading the proposal, this proposal is helpful for contracts written in languages such as Solidity and Vyper, because they had the case of clashing when we are claiming to the memory storage. By any chance, are you aware of any other ways by which the dapps, those are not written in this Solidity or Vyper, can make use of this standard?
Well, one thing is that even in the Solidity version, we are so low level with storage slots that basically the implementation needs to resolve to YUL assembly. So the truth is, it's not even really a Solidity implementation, it's as it is a YUL implementation to some extent. So I'm honestly not very familiar with Vyper, and I'm even less familiar with LLL or other EVM targeting contracts. This ERC, obviously, like a lot of ERCs, like ERC-20, for example, defines standards through the Solidity interface, because that's what developers are mostly familiar with. But the truth is, what we imply Solidity encoding and decoding, but the underlying thing is that we are designing things that are very low level, that are EVM. For example, in ERC-20, when you are defining the transfer function, you are just defining a message signature for first byte, and you are defining a way to encode a call. When you send it to a contract, you are expecting changes. And here it's even truer in the sense that we are sending this ERC around a storage slot, which is basically very low level EVM consideration of how to do an mstore assembly call. And we are also designing events, and events, we write them in Solidity for ease of use, but in the end, it's just like a log assembly call that people could do like in EVM assembly if they wanted. So despite us using Solidity, like most other ERCs, honestly, to describe what's happening here, it's not tied to the language by any way.
All right. But that brings to another question, like we can clearly understand the relationship with this proposal and Solidity. Obviously, there are many more proposals, many more ERCs especially, which are related in Solidity. I found a very unique comment in the proposal. I understand there is an open pull request to move it to the last call. It was mentioned that please pause pending that there is this issue. I'm going to share the link in the chat. Says that so that we can link to Solidity project commitments rather than public comments from developers on that project. I am not sure if you are familiar with that comment or not. I just have shared the link in the chat.
I can comment on this.
Oh yeah, thank you.
Yeah, please do.
Yeah, so what Pooja is referring to here is in the EIP, there is a basically a link to a tweet by one of the Solidity core developers, where he essentially promises that the language is not going to change the way that storage variables are laid out in a contract, right? In a Solidity contract. The reason why that's important is because as we spent some time today discussing the specific slot that was chosen, right, to store these values, and it was chosen in order to not clash with the way that Solidity lays out values in storage and specifically mappings. There is some potential that a language, a compiler, something like that could define a new convention for putting values in storage that would conflict with the values that we chose here, right? And by this we mean that simple code written by the user, right? Like high-level code without resorting to any sort of assembly or low-level opcode and so on. A simple contract like that should not clash with the storage lots that are defined in the EIP. So this question is, can we change the EIP so that this is like a stronger guarantee by the Solidity project and not just a tweet? This is what I think William was suggesting, and I think it makes total sense that it should be a stronger guarantee by the team. Regarding how this affects other languages, it's an interesting question. I find it extremely unlikely, and being the EIP in review and hopefully soon in last call, someone might be able to point out that this is not a reasonable expectation, but I find it extremely unlikely that any convention in any current or future smart contract language would in fact clash with these storage lots, just because of the way that it was defined, which is the hash of a string -1. And if there was a language that did clash with this, I hope and I feel pretty confident that we would know about and learn about this, and that language would need to be changed, honestly, because this EIP is, I don't think we gave the numbers, Adrian, right? But it is actually quite in use in mainnet and elsewhere. So people might would in fact probably detect this.
Yeah, I tried running some numbers today. We don't have an exact figure because it's hard to detect it, but the number of transparent or UPS proxy, so proxy of any kind, whether they're Open Zeppelin or others, that are both using our event upgraded and the storage slot for the implementation, this is about 5,000 contracts on chain. Now we also defined the beacon, the approach, and we rediscovered that for the beacon approach, there is way less, collision on the event space, because this is where the events we defined is not used by other proxy types. And we're able to figure out an exact number, and there are 25,973. So over 25,000 contracts that use this beacon slot and this beacon design already. So, I mean, I don't like to say that, but like this is already widely adopted, and and even more than what we ourselves expected. So that's, I think, one more reason say like, hey, this is not just something we want to push, but it's something that already gained a lot of attraction. Hope, I mean, I think it's always bad to standardize after the fact, using the adoption as an argument, but we are here.
That's pretty interesting. So just one follow-up question on that. I found this comment on the Solidity GitHub. So I'm just wondering, like, how is it the responsibility of the author or the proposal, and why is it so much required that this should be resolved first before we can move the proposal to the finals? Just changing some of the specification will help.
I don't necessarily share the opinion that it's so critical that it should be paused, that it should pause the EIP. So yes, I mean that's my answer. I don't really think it's that critical to pause it. I mean, completely in favor of documenting assumptions, right? And documenting guarantees, and Open Zeppelin contracts is always completely in favor of stability and backwards compatibility. And this actually is something that we also try to convince the Solidity team often to prioritize as well, which of course they have a trade-off with evolving the language and not making breaking changes. But anyway, this is to say, I'm absolutely in favor of documenting this. I just don't think that it's a very strong reason to pause it. And I feel that the ecosystem would benefit much more from moving this forward into last call and eventually finalizing it, as I hope most EIPs could do that faster.
And as far as I understand, this concern is about if Solidity decided to change the way they use or any language uses storage from the high-level code to the low-level execution on EVM, this would possibly break contracts that are upgradable using EIP-1967. That's true, but they would be breaking much more. I mean, Solidity team has a tendency to do a lot of breaking change during versions, and I think that's okay. The language is evolving, it's very soon. One thing that never broke is the storage layout. I mean, this is the main thing that they are keeping in line with, because they understand the importance of that. And if they were to change that, it would affect EIP-1967, but it would affect a lot of other ERCs. Basically, anything that is related to how storage works during upgradability would somehow be broken by that. And this might include ERCs that are already final. So, I mean, it's really a concern. It's a concern for us, but it's also a concern it would be a concern for the entire ecosystem if that was to happen. And this is something we need to document, as Franz say. Maybe the Solidity team could make a stronger point that this is something that they really, really don't want to change, but we don't know what the ecosystem will be in 5 years. Maybe there is no way for them to guarantee that they will never change it. And we should not stop all development of standardization of upgradability contract just because this might one day change.
Absolutely. The standards that are being documented today is based on the present infrastructure that is available. So it makes total sense that whatever is proposed, if there is no changes suggested to the proposal, it has a fair chances of moving ahead. Thank you. I believe Alita has a question.
Yeah, so this one's kind of broad. Well, not really broad, but I'm just wondering, like, there's been a lot of discussion about the storage slot collision and how that's being prevented, but why is that so important? And maybe you can offer like if that were not the case where it was prevented, like what could happen? What's the worst that could happen?
So let's take an example. Let's imagine a contract that is upgradable, like what we're designing here. And there is a slot somewhere. Let's say like it's like a drawer somewhere in your office. That is where you're recording the address of the implementation of that should be used. And this is very critical. If you modify that or change that, the proxy will stop working altogether. It will be like closing the road just in front of your house. Your car cannot go out anymore. If that slot is not modified, if the road keeps being directed correctly, everything works well. Now, let's imagine the contract that we are discussing is an ERC20 token. And someone's decide to transfer assets from his wallet to his father or his brother. And the father or the brother has no token yet, so their balance is 0. And when you do a transfer, this balance will be changed from 0 to 1 token or 50 token, depending on the amount that was transferred. Now, this new balance, the balance of the receiver wallet, this is also a storage slot. And if you are keeping that in a different drawer, then there is no issue. But if for some reason there is a clash, meaning that the drawer that you use to store the balance of the aunt ends up being the same, where they use as the implementation, where there used to be an address that was guaranteeing proper functionality of the contract. Now there is a number that is not an address. And whenever this number is going to be interpreted as an address, it would lead nowhere. So you would, what we call breaking the contract, like it would not work anymore. And that's really important. And it's also true of, let's imagine a contract that is ownable and that is ERC20. When you do a transfer, you don't want the owner to change. So you need those stuff to live in very different places. The Solidity, as we discussed, ensured that inside the contract, inside a single contract. But when you are having a contract and a proxy that delegates to it, those are developed in parallel. And you have to make sure that there is no conflict there either. That's why we are selecting these like random slots that Solidity would never assign.
Thank you very much. That was an awesome explanation.
Thank you. So my next question is related to the implementation in Open Zeppelin. You did talk about like the proposal is implemented, and even the proposal 1822 was implemented. So I'm trying to understand the necessity of implementing the proposals, Ethereum improvement proposals in a dapp, and also how simple or complex was the implementation of EIP-1967 in the Open Zeppelin?
Okay, so first thing is how important is it to implement an ERC? Well, I think ERCs are just a way to advertise to the other members of the community how to interact with a contract. If you explain to them how to interact with something that doesn't exist, that might be very interesting to think about, but that's not going to produce any actual results. Like we can discuss standards that don't exist, but like we could do theory about what road you would need for a car that has square wheels, but until you build such a car, the road is meaningless. So that's really our case. And that I don't really like to say that we need to standardize after we develop, because that's always a bad thing to do. But if we standardize to not implement, it doesn't make such sense. Now, about the ease of implementation, I think that implementing this ERC is really simple. Like I've seen implementations today just trying to figure out number. I discovered that this Ethereum project did implement it, and I was not aware of that. And their implementation is maybe 20 lines of Solidity, maybe 15 lines. It's very, very small. Now, obviously, Open Zeppelin implementation might be complex because we worked with it for a long time, and we designed it in a specific way that we wanted to provide tooling and an abstract function and that kind of things. So obviously the code might look bigger, but really like this ERC, as we discussed, is about those 3 slots and those 3 events. And emitting an event is something that all Solidity developer knows how to do. And writing to a specific slot, it's not the most basic thing because you have to resort to assembly, but it's one of the most simple assembly thing. And it's just 3 or 4 lines of Solidity that all developers would understand if they were to see it. So again, it's as far as it's really like at Open Zeppelin, we have a tendency to implement a lot of ERC when they become final. For example, ERC 27, 21s. There are ERC like 777 that are really complex to deal with. And I'm sure a lot of developers are happy that we're providing an implementation because they would have a hard time building this on their own. Here for proxy, it's not the case. It's really simple.
Well, this is pretty interesting, like ERCs is to advertise. Obviously, like when we are trying to make a standard, they would want some implementation to be done. Like if project is already implementing it, it is always helpful to push the proposal towards finalizing. And if a proposal is being finalized, we would like to see some implementation. So they are like going hand in hand. We can't separate them somehow. But it's good to know that the implementation for 1967 was not as complicated as it could be for some of the other proposals.
What I can add is that even though it might not be documented in the ERC, there are multiple implementations being used live on mainnet right now.
Yeah, well, actually, that is my next question. By any chance, are you aware of any other project who is actually implementing 1967?
So actively implementing it, I mean, a lot of projects are using our contract because, I mean, I've discussed that there are about 5,000 implementations in instances out there. Some are own implementation or implementation, some are other implementation, but the truth is almost none has been deployed by us because that's not what we do at Open Zeppelin. We don't deploy a lot of contract to mainnet. So that means that's saying that a lot of projects either created their own implementation and used it, or trusted us with our implementation and deployed our implementation through or the tooling we provide for it. So, and that's also one of the efforts is that once it's standardized, also if the implementation is good, there is no need to reinvent the wheel and to rewrite it from scratch. A lot of people are using what we provide and so far are happy with it.
I would also say this isn't since this EIP isn't really documenting specifying a smart contract, right? It's specifying storage locations. What does it mean exactly to implement it, right? And I would say that maybe Etherscan is not an implementer, but an integrator of this ERC because they read these storage slots in their application in order to show these read as proxy or write as proxy buttons here, right? Here, right. So it says ABI for the implementation using the EIP-1967 transparent proxy. So they didn't write their own Solidity implementation, but they integrated this ERC into their system.
That's pretty interesting. Like I remember reading something about this proposal is also facilitating some of the infrastructure providers. So yeah, it is a good use case there. All right. I have a kind of naive question maybe for people who are not very much familiar with these terms, or maybe they have seen these terms somewhere else, about the beacon contract address. So can you just explain for the people who may have been confused, like, is it anywhere related to beacon chain, or it's just a term that was used here for simple ERCs?
Yeah, so it's not related with the beacon chain at all. I don't know which one predates the other. The concept of beacon is pretty standard. Like the beacon chain is like a beacon for the Ethereum 2 world where it's signaling and generating finality. Here it's a way less cool beacon, but it's still a beacon in the sense that we have this smart contract that we call the beacon contract. That basically is advertising what implementation other contracts should use. And you have the beacon proxies. The beacon proxies, they latch, I mean, they are connected to the beacon contract and they use it as a reference. And one of the interesting usage of that is that if you have thousands of proxies that are all having a look at the same beacon, if the beacon change what it's signaling, like the bat signal in Batman, like if it's changing the shape, everybody's going to see it as once atomically. And that's how you can upgrade hundreds, maybe thousands of proxies as one using a single transaction that is pretty cheap. And maybe that's why we're seeing such high number of usage. I was really surprised to see like over 25,000 instances of this beacon proxy exist. But in the end, it really makes sense because if you're an application that has thousands of contracts that you want all upgradable, but you want them to all follow the exact same implementation and not upgrade them one at a time. This is really the design you should go for. And I'd like to add that we have recently been improving the tooling for interacting with this contract, and we had a workshop about that was yesterday. So if any of the viewer is interested on that, obviously it's way beyond the scope of the ERC, but Open Zeppelin is providing tooling and help for people to understand this design and decide whether they should use it or not.
I just want to make one small correction to something that Adrian said earlier. The beacon pattern wasn't introduced by Open Zeppelin. We adopted it, but it was originally developed by the Dharma smart wallet. And it makes a lot of sense in that context because, well, we just heard, I think today or yesterday, that they're being acquired and the Dharma smart wallet is being discontinued but it is a smart wallet that is a smart contract that is deployed for the user. And so they have to deploy many different instances of the same contract and upgrade them at the same time. And in that context, it makes a lot of sense to use the beacon pattern because of the properties that Adrian just mentioned.
Thank you for clarifying that. My last question for today is about the readiness of the proposal. I am curious to understand, like, what made you think that proposal should be moved, should go ahead for a standard? Is it like the implementation getting finished in Open Zeppelin? Is it the community feedback or any other thing that may have triggered decide pushing the proposal now?
We did some, I mean, this ERC is pretty simple and doesn't have a lot of movement. There was movement about maybe 6 months ago when we described the beacon inside this ERC, because it used to only be about like the implementation and the admin slot, and we added beacon so that it fills the entire scope of Open Zeppelin's visions of upgradable contracts. And really, we feel like we are at a phase where we feel like the content is clean, is defined. I mean, we could change the documentation and like the references, that kind of thing, but the actual technical proposition is not going to change. And we feel like it would be interesting for it to be terminated, just to give more confidence in people potentially implementing it. Because I mean, when a proposal is not final, you are always scared that you might start implementing it and then it change, and then you're not following it anymore. So that's also to say that, hey, this is the standard we are using right now. This is not going to be changing anytime soon. If it's changing, it's going to be another ERC, but we are not planning on that. And we are also going to focus on other things, like this is final, so we can focus on improving 1822, or maybe work on the diamond pattern or something else. But like, to us, like, or like it's exactly the thing you are seeing on screen right now. Is that we have this division of what the proxy space is, and there is this subset of the tree that has one need, and we think this ERC addresses these needs. And so we are finalizing it because we want to focus on other needs of this part of the tree, or on other part of the trees as well.
That was great. I don't know, we have a couple of minutes left for this call, but I would quickly like to touch on the diamond standard that you just mentioned. I heard that this proposal is somehow affecting diamond standard. I mean, would you like to talk a little bit about that?
So I've been an implementer of the diamond standard when it was not even called diamond standard. To me, that's called 1538, because that was the old name of this proposal. And diamond was just like rebranding it, but the technology is the same. And I've been developing ERC 1538 when I worked at iExec. So we're coming back to the early stage of the calls. And this 1538 is also used in production by iExec, amongst other, I guess. 1338 is different in the sense that you are not delegating to a single implementation, you are delegating to multiple implementation. This means that you cannot just store the address of the implementation. You have to store at least a mapping that goes from byte 4 to addresses. So the amount of data that the proxy needs to work with, to operate on, to work properly, is a different structure, is a different kind of thing. It's basically the same way that you would not attach your house to the road the same way you would attach an airport to the road. Like it needs different access because it needs to ship different kinds of vehicle and that kind of thing. So to me, there is absolutely no conflict between 1967 and the Diamond Standard, because they are discussing different proxy designs with different needs. And 1967 is about the proxy design for single implementation, and Diamond is different. Maybe this Diamond implementation will find that some of the things that 1967 proposes useful. For example, maybe not the implementation slot, but maybe the admin slots can be used by a Diamond proxy, and that's fine. Maybe a Diamond proxy may want to have their own storage layout for the Diamond routing, and then use our admin slot for the administration part. But I really don't see them conflicting.
That's good to know. I mean, I know that Diamond Standard is still in the last call and it hasn't moved from there, but it's good to know that they are not conflicting.
And also, if I'm not familiar with the very latest change of Diamond, so maybe I'm not up to date, but last time I checked, the Diamond was about standardizing the idea of a proxy that acts as a router, and about standardizing what they called the loop mechanism to see that. But this implementation, Diamond implementation, doesn't standardize specific storage slots. They let any developer implementing in any way they want, and then they standardize way to read these slots through view functions, which is a bit different. But this means that in Diamond is more about how to design that rather than what specifically you should do at a very low level, which is what 1967 does. So not only are they addressing different problems, but they're addressing them differently. I would argue that maybe one of the reasons why Diamonds are conflicting implementation and has not been moving faster is maybe because it's more difficult to standardize this storage slot, which is a very important thing, because if you're not standardizing that, different implementation might not be fully compatible. So that's, I mean, the Diamond standard is objectively way more complex. That's much more moving pieces. I personally think it's really great. That's why I implemented on top of it. Open Zeppelin has not been addressing it, first because it was non-standard, but also because we think that the tooling required to work with it securely is much bigger. And unless we're ready to provide the tooling for that, we're not going to provide something that user can shoot themselves in the foot with. So, I mean, I'm pushing forward using it more, but I also understand that it's kind of difficult, and it's really two very different things. Maybe Fran wants to add something about that, I don't know.
No, I completely agree with what you said.
Interesting.
Yeah, just a very small comment, but I was just thinking that even though they are like, in a sense, competitor standards, right? I mean, they both define different kinds of proxies, right? So one has to choose one or the other. I feel like the standardization of both, including 1967, benefits both, right? Because it makes sure that there are no conflicts. Like, for example, if the Diamond standard decided to use the same storage slots for a different purpose, that would be bad, because it would make integration very difficult. So the fact that 1967 becomes finalized just kind of gives a stronger assurance that that won't happen. So I feel like standardization really benefits both projects in this case.
Really? That's interesting. Like I saw that comment and it was like quite confusing. Like should Diamond standard be having some specification changes, because this particular proposal is providing more flexibility to actually implement the proxy standards. Well, it's time to wrap up. Any final thoughts or advice that you would like to share with the rest of the dapp developers implementing this proposal?
Well, if there's anything that you want to discuss, anything you need help with, feel free to reach out to us in the forum. That would be the best place the Open Zeppelin forum at forum.openzeppelin.com, or of course in the EIP discussion.
Sweet. We appreciate you both joining and talking about EIP 1967, which I think is being used and will be used with some of the other projects. So all the best for moving the proposal forward. For people watching the recording, the current status of this proposal is review, but we have the pull request up to move it to the last call. So if you have any questions, comment, concerns, or any suggestion related to this proposal, this is the best time, as Fran mentioned, that you can either join the Open Zeppelin forum or go ahead with the Fellowship of Ethereum Magician thread that is added to the proposal. Share your thoughts over there. On this note, thanks to all our YouTube viewers for watching, sending us questions on different proposals, and letting us know that how they are implementing their proposals. For today's episode, if you have any question, you can obviously leave a comment. Check out the description section for links and a guest Twitter to follow. If you like this talk, hit like and share. Subscribe to the Ethereum Catalyst YouTube channel if you haven't done it already. We'll be back with another interesting proposal. Till then, keep watching.